So do you hear me? Probably right, yes. So welcome everyone. It's 4 p.m., so thank you for coming to hear about sexy data. So I had to make some catchy title because who the hell wants to talk about data and hear about data at 6 p.m., but at 4 p.m., sorry. But yes, yet here we are. And first of all, also thank you to the organizers for inviting me. Thank you again for coming. And yeah, first of all, we probably need to get to know each other. So I will talk about myself for like a minute, and then I will ask you some questions. So my name is Łukasz Mróz. I'm from Poland. I'm working as an iOS developer for about more than 3 years now. Before I was working as a PHP developer, then there was a 1 year of JS and jQuery, so I've been around for a while. But yes, nowadays I do a lot of iOS and open source. From my open source works, I maintain Moya and Swift user defaults. Anyone use Moya or Swift user defaults? Hands up, please. Okay, we've got someone, thank you. So yeah, that's basically it. I'm doing a lot of things, and I will release some pretty nice tools for iOS. So you want to follow me on GitHub or Twitter, if that's the case, if you want to follow my tools. And then I also wanted to ask you, how many of you actually do any iOS development? So please raise your hand if you're doing iOS development. Thank you. We've got someone, okay. And if you're doing Swift development still, please raise your hand. Swift? All right, almost similar. So if you're not doing anything I just said, please raise your hand. There is someone who's not doing iOS or Swift. Okay, no one. Oh, yeah, there's one guy. Okay, 2 guys. Sorry. So some of my talk will be we won't be touching really Swift, but most of it will. So sorry for that. Okay, probably we can jump to the topic, which is talking about data. And before I really want to start talking about data, I was asking myself, what's an application? What is it really an app? And I was trying to express myself with some kind of words, etc., making a definition, but I couldn't really find one. So I was browsing through some beautiful apps on the App Store, and then I found out I found out something like Bear. Anyone used Bear here? Heard about Bear? Okay, we've got someone. So Bear is something like an upgrade over Notes app from iOS. It's really beautiful. If you ever use it, you probably won't be using Notes app at all. It's really beautiful. And when you think about it, this application has a lot of data in it. But it's really showing beautiful pictures instead of it. There's no raw data. You don't see really a blob of data, any JSON here and there. It's just a beautiful application. So I probably could stop with just saying like this is an application, but I heard one nice quote from Orta, which is, apps are just pretty pictures of JSON. So I might agree with the statement, mostly because JSON is just a data format. It's something that is represented by data. So apart from the JSON part, it's mostly correct, and I like this one. So yeah, if you ever wondered, apps are just pretty pictures of JSON. But when we start from the very beginning, there's a blob of data. Yes, you can make a screenshot and then tell me what is it about. But basically, it is just raw data of the JSON that I will show you afterwards. And yeah, if you put that one instead of the beautiful pictures that we saw before in the Bear app, probably your user base wouldn't be as big as the user base of Bear app. So we need to do something about the data, transform it. And then we came to this JSON format. It's pretty readable, probably, if you get a chunk of it. Even the normal user that's not a developer will probably understand something in there. But it's still, if you were to create an app that's basically an input and an output is a JSON, you still wouldn't really get the fan base, the user base of your app that you want. So let's go deeper. So we have a pretty printed version of JSON, and that's a sexy format of JSON, and I really like that one. But yeah, this is me, and I could probably finish the talk right here. But for the users, pretty printed JSON is probably not the pretty picture of JSON. So we still probably need to dig a little deeper. So for users, it's not pretty, but how about developers? So I asked a few of my colleagues, developers, what do they think of JSON? I needed like one statement, so I asked 3 random colleagues, and this is what they told me. JSON is boring, JSON is incredibly slow, and JSON is a good friend. I don't really understand the last one, but I will focus on the first 2. So is JSON really boring and slow? For me, JSON is really a challenge. So who was here? Who was doing JSON iOS or Swift development when Swift was version 1, the very first? Who was doing Swift back then? Okay, so 2 guys. That's great because I had a really bad joke about Swift 1, so I won't go there. But yes, so if you don't love me at my worst, then you don't deserve me at my best. This is a remix of a pretty popular meme tweet from Harlan. You can look it up. There's a link down there. But basically, at the top, you have something that we had to do in Swift 1. This is probably 1.2, if I'm not mistaken. So as you can see, this is not the best version of parsing JSON. And then you wonder, how the hell did 10 of different libraries for parsing JSON exist? So this is probably the reason why, probably because it's not really useful that way. It's not clean. The dependence, the closure hell that you probably see in asynchronous programming really gets to you. So this is not the best. And then you see what a long way we come. This is a JSON decoder. About 3 years in the works, we have finally a nice decoder for the JSON format, and not only for the JSON format, because Codable as a protocol can do a lot more than just do a JSON decoding. The JSON decoding and encoding is just the default implementation that we have from Apple. We can do a lot more. There's a JSON RPC format, data format that's similar to JSON, but we can still implement something like decoder for JSON RPC as well, and many more. But you really see that we've come a long way in the span of about 3 years, and this is not something that should be considered easy. Maybe it's simple, who knows, I can't really tell, but it's definitely not easy if multiple programmers, experienced programmers, worked on a pretty clear API to implement something like this. And then there is a guy called Matt Thompson. I'm not sure if you know him, but he's a owner of NS Hipster. So for these guys that know the old ways of Objective-C, etc. So NS Hipster was really popular back then. And then Matt created frameworks like Alamofire, IF networking, and then came to Apple, and then we all forgot that he exists. And then he came back after quite some time and launched a new project called Flight School. Flight School is a project. I'm not really sure exactly what it will be, but Matt was saying that he will create a few books at the start. And the first thing he did after coming back from Apple is a new book for Swift Codable protocol that has 140 pages of just explaining how to play with JSON and JSON Codable. It's not just that, because as I said, Codable is a lot bigger than just JSON, but you can sense how hard it might be to understand all the concepts of decoding and encoding. So it might be something down there. So people just try to dig down deeper to understand JSON and encoding of the data in general. So this is another representation of JSON. So this time we will see some performance. So this is a diagram. You probably don't see the names down there. It's not really important right now, but basically you have like 10 or 15 JSON mappers that do exactly the same thing, map and deserialize JSON. And as you can see, the bars are performance. And there are some libraries that are not really performant, but on the other hand, Argo, which is the last one, it has probably the biggest bar. is a functional library, so it gives us back something else that we maybe need. And this is probably a good thing for your use case. So whenever you try to use some mapper, you probably should understand your domain, probably understand your needs, because as you can, you probably can't see, but Codable is not the most performant one. Probably it's Marshall, if I can see correctly, the red bar as well is counted. So maybe Marshall would be a more optimal way to do stuff if your application is just a pure representation of, okay, whatever I get from the API, and then parse it for the user with some cute pictures and nice design. So depending on your use case, you probably need to figure out if you need a functional approach, or maybe you need some performance up there. Maybe you need something that you write in your own spare time, because maybe Marshall is still too slow. So maybe you need another data format. So there are a lot of questions regarding JSON. It's really interesting if you think about the underground way of that. So I was talking about JSON parsers, and as I told you, I work in JSON. Right? This is a software house. To understand what I'm going to say to you, we need to explain how software houses work. So let's say Facebook wants an app, and Facebook doesn't really have engineers to implement that app. That's hypothetical. And then they look for a software house or a freelancers, but they're looking for someone to create that app for them. And software houses are that type of workers that do that stuff for the client. And when you work in a software house as a developer, you probably will have like 1 to 3 projects in a year. So maybe you will start 3 new projects because these projects were quite small, or maybe you'll spend like 2 years on a one project. So it's kind of random and probably kind of what you want to do, because in many software houses there is an alternative. You can move around stuff and move around teams. But basically, Wrocław is a big city of a lot of software houses. And we have this meetup in Wrocław, and we talk a lot with other software houses. How do they feel about projects that they have and what they do? And the one topic that comes quite often is something called JSON parsers apps. So basically, you have an app that fetches the data from API and then presents to the user in a pretty way, but still there's no logic, no big logic, maybe some animation, etc., but still there's no logic going on there. So these are the JSON parsers apps. And when I hear about them from colleagues, it's most likely, this is another JSON parser app that I need to do, or still that boring stuff, And then I think about all the things that I talked to you about before, and I'm like, whatever floats your boat, because JSON is not that easy task to do, and when you write one app in a year, so much can change from one state to another. So yeah, that's basically JSON parsers. And what I think is we should care more about data and in general. So whenever you say that JSON is really boring and nothing to do there, you probably miss some things that should be there. For instance, if you are working with API guy, if you have an access to the API guy, and you see that your JSON payload is really big, so there are fields that are not necessarily, that shouldn't be necessarily there, like secure hashes or credit cards. You don't really need credit cards, so why is it there? So not only security, but also, for instance, if you have a big chunk of data that is based on user content, so for instance, if you have a list of job offers, and the job offer list grows as the user adds content. So if you then don't have pagination, you're risking both your backend, your application, because parsing a quite big chunk of JSON is not the best thing to do, and then you risk your product, because, well, if you can't parse one response and your one response is 5 million entries, then you have a problem with your performance. So I talk a lot to people to try to change it, because it risks your job if you're working in a product. It risks it risks that your app will not be as performant as you want. So there are many things to consider, and people just say, whatever, this is one simple app, and what can happen? Pagination is not really important. And you might think, okay, pagination is the simplest, stupidest thing in the world for API designers, and you might be so wrong, because when I talk to the API guys and to the people that do iOS stuff, and I see some apps in a consulting role, this is really a problem. So whenever pagination is not the only thing you need to consider. This is just an example, but if you see something that you can change and you care about your data, please try to change it. You might even say that you might need to treat your data like a princess. You need to understand her domain. So this is the first thing that came out of my head when I thought about princess, but don't really go into deep that. So this is the first screen that popped in my mind. So Swift 2 to Swift 3 migration was really hard, because there was no stability that we have right now between version 3 or 4. The migration from version 3 to version 4 is a little minimal. For like big projects, it took few hours to like 15 minutes. So this is the migration from Swift 3 to Swift 4 is quite easy. But when you think about the old good days, when you have like 2.3 to 3, it was really a challenge. So when you run the migrator, you still had 10 times more errors. So even though we had some automatization, we still couldn't rely on that. So you need to ask yourself a few questions, even if you're doing a migration of Swift. So many people just say, okay, Swift migration, whatever, we just do exactly the same thing. This is like paperwork. We do this, we do that, we move stuff, etc. But it's not that simple as you might think. So if you're doing a Swift migration and you need to work with multiple people on that. So if you're working alone on the project doing Swift migration, it's fine. Probably it's fine. After 2 weeks, if you can't really do the migration, you either resign from your job or probably need someone else to help you or start from the scratch. But then if you have multiple people, you need to organize things. So how do you organize these things if you don't know, if you want to don't copy your work, don't make too many merge conflicts, or there are many more things about that. But basically, you need to figure out if you split your work on parts, or if you work together in pair programming, if this is the two-person task or whatever. So this is a very basic question, but still brings a lot of another questions to that. The second one, if you don't have dependencies in your app and you're migrating from Swift version 1 to 2 or 2 to 3, it's all good, because you don't really need to depend on dependencies. But whenever you have dependencies in Swift 2 and you want to migrate to Swift 3, things are gonna be risky, because if you're using UI libraries and they tend to not update the Swift version, you probably end up implementing your own solution, or if this is a simple app and your dependency is everywhere, like reactive programming, so you probably need to start from scratch your app. So this brings us to another question. What if one dependency does not work in the newer version? So what do you do? And you need to think about those stuff before, because let's say we did spend like 1 week on Swift migration, and then after 1 week, we figure out, okay, this one dependency, Rx Swift doesn't work, then they stop the work, so everything is reactive Swift right now. So what do? You need to rewrite your whole app, or create your own fork, or maybe someone did it already, probably would, but this is still a guess, because the domain of Rx is really hard. To make a good copy and do a good upgrade, you need to have the domain knowledge. So it's really hard. So if you think about this stuff before, you might earn some days for you, because starting from scratch, you know, things happen. And then if you're migrating from Swift 2 to Swift 4, how do you do it? Do you start with migrating to Swift 3 and then to 4, or just jump straight to the 4? If so, do you feel like your team members know enough Swift to go straight from 2 to 4. It might be easier if all of you understand the changes, but what if only one guy knows and the second one doesn't? He will feel lost in all the things you guys are doing. So this is also really important. Do use a migrator. As you can see, as you saw before, the migrator is not enough. You need to either do code review or I don't know, create your own migrator. So do you use it? Do you use any automation? Do you trust your tools? Because you can't trust them right now. So if you have a bigger project, you probably will encounter some problems that you need to go over with. So code review still is some time after a bot, actually. How do you test your app after the migration? So the first question would probably be, do you have unit tests, the automatic tests, any tests automatic? If not, you're having a problem, because if you're not having tests and then you migrate a big code base to the newest version, and you probably need to migrate 2 versions because there's a 5 in the corner. So you want to migrate a big code base, you have no tests, you need to do a full regression test after quite some time. And if you skip regression tests, you're in for trouble. So you need to plan those tests, probably not in the start, but still there's a question that should be asked before you finish. And the hardest one, which is, do you do refactor while migrating the code base? So let's say you have an app that is 1 year old, and you do the migration, and you see some skeletons here and there, and you want to fix them on the spot because it's easy, right? So for instance, I have a line that says there's an if statement, and back then there wasn't guards, and there is a guard right now. So I need to change this one line from if to guard. It will make my code a lot easier. So though I do it on the spot, this is a tough one, because if you recall, guard and if statement have inverted conditional statement. So whenever you change if to guard, you need to remember about converting to a negative value. And if you forget about it and you don't have tests, well, you need to pray to the God that your regression test will catch that. Otherwise, if that's a big feature, you kind of lost. So this was the hardest one for me. But there are other questions just for a Swift migration that seems to be pretty simple and pretty boring. Not so much. And then we need to handle all the states the data might be in. Another real-life example. So this is a pretty simple, basic table view. The idea is that we fetch some data from the server, and then we load the view. There's a twist in there, but let me just show you this line of code. So we are not talking about architecture there, okay? So this is a perfectly fine code in MVC. Please avoid any architecture talk about that one. If I had to implement some architecture layers, we'd probably spend 15 minutes on explaining them. So let's just say this code is perfectly fine, and we just fetch the data from API. There is a call that says, okay, fetch the data, and when the data is fetched, save it to a property of the controller, and then you can reload the table view because you have the data currently locally. And that's pretty fine. And then we have something from the designer. There's a loading screen. And as I was saying, there is a twist in the right top corner, which is a refresh button. What does it do is, whenever I touch the refresh button, I need additional state in the view, which is loading view, and then I need to form the data afterwards in the table view. So we're thinking, well, pretty easy. Let's just add 2 statements here and there, hide the table view, show loading view, pretty easy. It is probably the last thing we're gonna touch in that controller, because why not? This is the only state that we can have afterwards, yeah? So we add this one and we think, okay, let's never touch this method again. It's perfectly fine. And then we forgot that, okay, what happens if there is an error state? Well, nothing bad happens. Let's just add another piece of code, one if statement, whatever. I understand everything. And then year after, your designer tells you, okay, we need an empty state. And no one really understands what's going on there. So This is a pattern you can avoid. And how can we avoid that one? We can avoid that by explicit states. So if you recall, there is a state in this table view. The state is implicit because no one really knows what the hell is going on there, because you need to know the domain and that there's a loading screen error and everything about that one method. You need to study it to determine that there is a state. So a better way to do it will be an explicit state that we save in a property. So there's an example. I forgot about the error state, but you got the idea. There's a layout which is a state of the view controller, and you have a state which is empty, loading, and content. And then we have a method to update that state. And we do pretty basic stuff. You can also implement a pretty big state machine here, from one state to another, etc. This is just a plain example. If you would have like a bigger task to change the layouts, like adding, removing child controllers, etc., you probably need to make some sub-functions to that one and call them in the case. But basically, that's the idea. You could implement the explicit state and work from here. You need to let her know that you care about her. We still are talking about data, don't forget. And then we need to take care of her even when the data is offline. So taking care of application that uses offline mode and offline state is pretty hard. I'm not going to talk about the whole offline mode and how to do offline states properly, but I wanted to touch two things that are not really popular, but I think should be more popular than are right now. The first one, caching responses and policies of caching, and then we have recording and using stub responses. The first one, I'm not sure if you know, but in URL requests, there is a property called cache policy. So basically, the default implementation of caching policy is whatever the protocol gives us. And when you have a problem with, okay, so I do one network request and then I have one response, but my colleague does another request and has completely different response. What's going on? And it's really hard to find out what's going on because this is might be connected to caching policy. And when I want to avoid caching and the data that I want to catch should be always fresh, there is a property for that, and we can call reload ignoring local cache data, which just forces us to use the new data all the time. And then the second one is recording and using stub responses. So let's say we have an app that is really connected to the internet, so you need the network connection all the time. You need let's say your app doesn't work without the internet. We don't care about offline. So you need to be always connected to the network to make your changes. Let's say you're in a flight. Well, if it doesn't have Wi-Fi, you can't really work on anything. So you can watch Netflix. But who want to watch Netflix when you can care about your data? And you can record stuff. And there are multiple libraries that helps you record and use stub responses. Stub responses is whenever you do a request to the API, you get the response, and you save the response that you can use afterwards. So let's say this is an API without the network connection, some sort of a local API. And you can use it with OH HTTP stubs, which is mostly for stubbing responses. And then there is there are network abstractions like Moya. Moya is completely different because this is a whole new layer of abstraction. So if you want to use Moya, you need to read carefully what it does because it's cool, it's good, but maybe it's not good for your use case. You need to figure it out yourself. But basically, yeah, try to use stubbing responses and recording responses. One of the last tips is please don't pass the data to the wrong guy. And what I mean by that, there was a talk about architecture and how to pass the data, but I'm gonna just skip through most of it. So there are intermediate objects like viewModel or renderable. These objects are quite similar. So basically the idea is when you have a view, the view is dumped as hell, and you pass some object that is only mean to be rendered, which is renderable, or just viewModel. This is almost the same thing. And then these objects are testable, and you do not pass any data that you don't want to. So let's say you fetch some requests from the network and you pass all of it to the view. And the new junior comes and you expose all the API to him and he doesn't really know what to do, and you still expose this function to him and you can't blame him to use it. Architecture patterns are hard and you should make it as easy to reason about as possible. So please use intermediate objects for that matter. Sometimes you have a network request that doesn't really need an intermediate object because you just get the plain data from the API. So don't over-engineer, because that's also a problem. Just try to be predictable, and your code should be more clear to other people than to you. So think about people here. And the second one, think about who is responsible for that data. So let's say we have a Viper architecture. We have interactor that calls the service, gets some data, and then what to do now. So do we pass everything to the presenter, or does even presenter need anything? So you need to know what to expose to who and what to pass to who. So the presenter probably doesn't need to know about everything. You just probably need to pass some state to him, and that's all. So passing the whole data is most of the time mistake. So for me, the best thing is to test what I really need from the interactor. If the interactor gives me some data, I can really test if it's enough for me or not. So testing helps with creating this type of objects that help you with passing the data, caring about her. The next one is handle your errors properly. There's an excerpt from my app. This is a print. That's not even a debug print, it's just print in the app somewhere there. So don't use printing. The dual catch is okay, but there are other similar solutions to that problem, and we can do a lot better. So sorted by effort, from the minimum effort, there is an alert for the error. So let's say you have a refresh button as we had, and then you click the refresh, but you had an error. Some of the apps just forget about it and do not say anything. That's, okay, something happened, but you don't really know if there's an error or if there's a new content. So alert is okay. You can say, okay, we had a problem, there's an error, don't use this app right now, or something like that. So alert is still cool because you inform your user that something happened. Even better alert would be, okay, so something happened in the server, but don't always say that this is a server problem because maybe you will be wrong, but generally better option is to specify what's wrong and how user can contact you about this problem. The second option would be to create a smooth component that's integrated into your app that doesn't really feel like an external component to you, which is, the alert is pretty external, so almost to any view, the alert will feel external. Maybe not to the Apple products, but most of the time it will. So create something that feels natural. The first thing that comes to my mind is, for instance, when we have input for a password, when you write the password right there, and then you click submit, and then you wait for an answer. You can not show anything. You can show an alert saying, okay, something is wrong. Please type your password again. But you can also make a component that feels natural. For instance, shake your input and make the border red, and maybe even go deeper and say, underneath little font, okay, your password is too short, make something longer. So that's the second idea. Third idea is silent retries in cache fetching. So this one is probably known more to someone who does reactive programming, because this is in every tutorial ever. But basically when you have network timeout or network problems, you should maybe think about retrying the request. But it's not that easy to implement as well, because some requests, mostly posts, or gets probably someone too, are really sensitive. So if you do the second post, maybe someone else would happen. So network failures are almost safe. Other errors are tricky. You need to think about what errors should we retry with that data. And then there is a cache fetching. So let's say we have that list of things in JSON that we had before, and then we do the refresh, and there's an error. We could show the error and an empty state in the app, but we could also show the table view that says, okay, this is the data from that time. You need to reactivate your network to get to the latest state. So be explicit about that this is a cached data, because if I'm saying something there, I feel like it's mostly up to date. I'm maybe not aware of my network connection problems. So you need to show it to the user. And the best option would be to do a pretty smooth UI component with retries and cache fetching. This is just my honest opinion. There are probably a lot more things to do with that, but that's basically it. And last but not least, you need to think about the data all the time. Okay, you maybe not, but I'm thinking a lot about the data, and maybe try that one as well, because that's a lot of fun. There are a lot of challenges that you might not see in the first place. So yeah, that's basically it. Thank you guys so much for having me, and if there are any questions, shoot. Okay, no questions. Cool, yeah, so thank you guys again.